Today in Lesson 6, we're going to look at histograms. Histograms are sort of a cousin to bar charts. Histograms are charts that summarize our data in intervals or groups. The bars are touching, there's no space between the bars, and they're usually the same width. Histograms are really good for giving you a picture of the shape of the data so that you can better tell if it's uniform, symmetrical, or skewed. So looking at an example, we have the speeds of some passing cars. The speed limit is 50 kilometers, but we have speeds that go in the 40s, in the 50s, in the 60s. So if we wanted to categorize these, sometimes people say it's like putting them into bins or putting them into buckets. So we have some buckets here. We've got 40 to 44, we've got 45 to 49, 50 to 54, 55 to 59, and 60 to 64. So each one of these holds 5 different numbers, or could hold 5 different numbers. Now we just have to put the values into the right bins. And it's magic. Okay, so now we have all of our values sorted out, and we can go ahead and make our histogram. So again, our frequency goes on the left, and our groups or our intervals go on the bottom along the X. So if we look at the 40 to 44, we only have one, so we want a bar that's 1 unit high. We also only have one of 45 to 49. In the 50 to 54, we have 3, so we want a bar that's 3 high. 55 to 59 is also 3 high. And then 60 to 64 is going to be 4, so we want one 4 high. So now we have a histogram, which shows us a good picture of the shape of the data. And hopefully you can look at that and determine whether that is uniform, symmetric, or skewed right or left. And it's a little easier for us to see that there's more people that are way above the speed limit than there are people that are below the speed limit. What about with intervals is not to overlap them. Many times students will make their intervals like 40 to 45, 45 to 50, 50 to 55, 55 to 60, 60 to 65. The problem with that is when you look at the number 45, which of the bins is that 45 going to go in? It could go here, there. Where does it go? Which one? We're not sure. Or if you look at 55 or 50, where would 50 go? 50 could be in here or in here. So your intervals need to be really clear. Okay, one more example with histograms. Here are some grades for a third period class, and you can see they're pretty spread out. Only 2 values, 90 and 83, have more than 1 dot. So this dot plot isn't a lot of use to us. If we made a frequency table for grades, ones that aren't standard based, usually the 60s are D's, the 70s are C's, 80s are B's, and 90s are A's. So that gives us a natural way to group them. So all we have to do is count the ones in the 60s, 1, 2, 3. Count the one in the 70s, 1, 2, 3, 4, 5. The 80s, 1, 2, 3, 4, 5, 6 in the 80s. And the 90s, 1, 2, 3, 4, 5. So now we've got our frequency table, and it's easy to turn that into a histogram. So our frequency goes on the left side, and along the bottom goes our groups. So for 60 to 69, I have 3, so I want a bar that will go up to 3. For 70 to 79, we have 5, so I want a bar that goes up to 5. For 80 to 89, we need a bar that goes up to 6. And for 90 to 99, we need a bar that goes up to 5. And there we go. That's our histogram. And again, you can see the shape of the data pretty easily, and you can get a summary of, well, only a few people got below a C. Most people scored a C or higher. So reviewing histograms. Histograms are A good way to represent data with a lot of single values or a lot of variability, where a lot of values aren't grouped together, you make a group and put them together. We use intervals or groups. Your intervals should be evenly spaced. There should not be any overlap. It should be very clear where a value goes, not that it could go into two different buckets. There's no space between the bars. And these histograms work really well with things like grades, ages, weights, speeds, things where you're going to get a lot of different numbers, different responses, and then you can put them into groups. That's a histogram.